Imagine you're out at sea, and suddenly a pod of whales breach the surface. One individual catches your eye. Is this whale starving? Will it survive another year? Is its baby healthy? These questions will decide the future of the population. And now, we can answer them without harming the whale. In fact, it will never even know we were there. Impossible as it sounds, you'll see exactly how it works in this video. Here's the problem. Whales don't make this easy. From a boat, you rarely see the whole animal. You get a tail, a fin, maybe part of its back. So for a long time, assessing the health of a whale meant getting dangerously close, which posed a risk to both the whale and the researcher. Until this changed everything. Instead of chasing whales through the ocean, drones enabled us to start looking at them from above. And that simple shift unlocked something powerful. From a single moment at the surface, we can extract two vital pieces of information: who this whale is and whether it's well fed or starving. It starts with the drone launched from a research vessel hovering about 30 to 50 meters above the whale, high enough so the whale doesn't notice and low enough to capture the animal in incredible detail. But here's what most people don't realize. You're not just filming, you're waiting, because almost everything you record is useless. What you need is one very specific moment, when the whale surfaces and its body is straight, flat, and fully visible. That moment might last less than a second, but if you catch it, you've captured something measurable. Before you measure anything though, you need to know who you're looking at. Because saying that a whale looks skinny doesn't mean anything. But saying this particular whale looks skinnier than it did last year means everything. And whales already carry their own ID. Look closely and you'll see unique dorsal fin shapes, scars, and pigmentation patterns. No two are identical, so we take that one clean frame and match it against a catalog, sometimes manually, but increasingly using artificial intelligence. And when there's a match, that whale stops being anonymous. Now it has a history and a future we can track. Now comes the part that feels almost impossible. We're going to measure a whale from a photo. Here's the trick. By combining the drone's altitude with the camera's optics, we can calculate how much real-world distance each pixel represents, allowing us to convert pixel measurements into actual size. Which means the image isn't just a visual anymore, it's measurable distance. So we draw a line, head to tail. That's the total length. Then we measure widths, a specific point along the body. And this is where things get interesting, because width tells you something length can't. How much energy the whale has stored. A well-fed whale is thick and rounded. A struggling whale becomes visibly slimmer. So from a single frame, you're not just measuring size, you're measuring condition. You can even estimate the whale's body volume, and from that, its total weight, which means that image is basically a remote health check. Now imagine doing this on a whole pod of whales, tracking the health of individuals and their relatives over their entire lifespans. It seems like a huge task, but now modern tools can scan hours of drone footage, pick the best frame, measure the whale for us, and even detect and ID the whale automatically. What used to take hours per whale now only takes minutes, which means we can track more individuals more often with far more precision. And that's where this really starts to scale. Now, this method is powerful, but it doesn't work equally well for all species. It works best when the whale predictably shows up near the same coastal areas time and time again, and spends a good amount of time near the surface, like killer whales, humpback whales, and right whales. So like most tools in biology, it's powerful, but not a one-size-fits-all solution. But when it works, it really works. Because now you can do something incredible. You can identify a whale, measure it, and come back later and do it again. Same individual, new data. And suddenly, you're not just observing whales, you're tracking their lives and health. You can see weight loss, recovery, pregnancy, and growth, all without touching it. This completely changes how we study marine life, because we've removed the biggest barrier, physical interaction, and the cost associated with it. Now, we can collect more data, reduce stress on animals, and monitor entire populations at scale. And most importantly, we can detect problems earlier, before it's too late. So what looks like a simple drone shot is actually something much more powerful. It's an efficient and ethical way of monitoring a whale's long-term health. And once you see it that way, protecting these magnificent giants won't be as impossible anymore. And if you think that's powerful, the way scientists can detect entire ecosystems without finding any of them is even more surprising. I'll link that video down in the description. Thank you for watching.